Module 7, Objective 4, define somatic sensory pathways and understand that there are numerous pathways, each carrying different input to the brain for processing. Somatic sensory pathways carry sensory information from the skin, from the musculature of the body wall, head, neck, and limbs to the central nervous system. There are three major somatic sensory pathways: the posterior column pathway, the spinothalamic pathway, and the spinocerebellar pathway. The posterior column pathway carries sensations of highly localized, fine touch, pressure, vibration, and proprioception. When considering these pathways, we have to understand the sensory homunculus. This is a functional map of the primary sensory cortex. Remember, the primary sensory cortex is the post-central gyrus of the parietal lobe. Remember that the central sulcus separates the frontal from the parietal lobes. The gyrus just posterior to that, i.e. the post-central gyrus, is the primary sensory cortex. So information, if you look at this figure, information from sensations come into the spinal cord. They go up the spinal cord. At some point they cross, eventually making their way to the thalamus, where then it's projected onto the cortex, and specifically this post-central gyrus. And if we look at that post-central gyrus, this single wrinkle, if you will, of the cortex, we see that all the locations of the body are found within the real estate of this post-central gyrus. So you have the foot in this general area. You have a very large region that is associated with the hand and the face. And then, of course, the trunk, the legs, the arms are located here. The reason that this sensory homunculus is sort of disproportionate, very large hands, very large face, very small body, is because more surface area is dedicated to the hand, to the face, than other parts of the body. And that's just because these regions are more sensitive, and they're more sensitive because they have more space on this post-central gyrus. So this sensory homunculus really is sort of a map, if you will, of the various regions of the body. So again, the distortions that occur because of the surface area of the sensory cortex devoted to particular body regions is not proportional to the region's size, but to the number of sensory receptors that it contains. So the regions that cover the hand and the face, they just have more sensory receptors. Therefore, they have more surface area to accommodate that sheer number. The spinothalamic pathway is going to provide sensations of poorly localized or crude touch, pressure, pain, and temperature. And again, these sensations come into the spinal cord via this dorsal route, up the spinal cord to the thalamus, before being projected onto that primary sensory cortex, where again we find this sensory homunculus, or this map, if you will, of the various regions of the body. Results of abnormality in the spinothalamic pathway: painful sensations that are not produced where they're perceived to originate occur. One example of this is phantom limb syndrome. And in phantom limb syndrome, the phantom limb, or a phantom limb, is the sensation that an amputated or missing limb is still attached. So it's the sensation that individuals who've had limbs amputated, they still feel pain. And we find that up to 60 to 80% of individuals with an amputation experience this phantom limb syndrome. At one time, it was thought that the phantom limb syndrome was due to inflammation of the cut nerves that went to those particular body regions. But now, while there's still a lot of argument as to what is causing this phantom limb syndrome, it's believed that it's extremely complex interaction of the brain. So there's really still a big question mark as to what causes this, but it is a very common or frequent syndrome associated with individuals who have lost body parts. Referred pain is the feeling of pain in an uninjured part of the body when the pain originates in a different location. And we see this all the time with heart attack. Individuals who suffer a heart attack, they're going to feel pain, or frequently feel pain, within the left arm and the left region of the chest. We can see in these little maps that different visceral organs sort of project onto these various parts of the body. So an individual who has pain in the ureters, this is a tube that carries urine from the urinary bladder to the urethra, they often feel pain in this region of the body, the lower abdomen down to the groin region. So these are just some maps of where these visceral organs sort of project that pain onto the surface of our body. The spinocerebellar pathway receives proprioceptive information about the positioning of skeletal muscles, tendons, and joints. And this makes sense since the cerebellum is responsible for adjusting postural muscles for balance. So you would expect the input of the proprioceptive or proprioceptors would be carried to the cerebellum so that they can make judgments for balance. Most somatic sensory information is relayed to the thalamus, but only a small fraction of that information is actually projected onto the cerebral cortex, i.e. reaching our awareness. So if it never makes it past the thalamus to the cerebral cortex, we are not aware of that particular sensation.